Welcome to Higher National Diploma in Accountancy. In this video, we are going to learn decision theory and decision tree. So the objective of this video is to give a brief introduction of the decision theory and to acknowledge you how to make decisions making under conditions of risk. So in this one, we are going to talk about expected value analysis, expected opportunity loss, and expected value of perfect information. Then we are going to talk about how we are going to make decisions under conditions of uncertainty. After that, we are going to cover how we are going to draw a decision tree, and based on the decision tree, how we are going to make a decision. Decision theory primarily concerned with decision making under the condition of risk and uncertainty. Decision theory deals with methods for determining the optimum course of action when a number of alternatives are available and their consequences cannot be forecasted with certainty. The environment in which decisions are made can be categorized into four types: certain environment, risky environment, uncertain environment, and conflict environment. The certainty exists when all the information required to make a decision is known and available. The condition of risky environment exists when perfect information is not available, but the probability that certain outcome will occur can be estimated. A state of uncertain environment refers to a condition in which the probabilities on occurrence in a decision are known, and in the conflict environment, the interest of two or more decisions are in competition. So we have to select either one of the options in this kind of environment. Let's see how we are going to make decision under condition of risk. For decision making under this, we must identify the following components. So we have to identify what are the causes of actions. Then we have to see what are the possible events that can occur and their probabilities. Then we have to calculate the conditional payoff for given course of action under the given possible events. So there are three ways we can calculate the conditional payoff. The first one is expected value analysis, the second one is expected opportunity loss, and the third one is expected value of perfect information. Let's see the example 1. Here, the ABC is a private investment company and is attempting to determine whether the investment for next year should be in stocks or bond. The investment alternative of possible events and conditional payoffs are in the table. So you can see the different alternatives of stocks and bonds, their probabilities under different economic situations. So in the 30% of economic uprising, the stock is give 1000, whereas the bonds give 600. When there is 70% of economic downrising, the stocks give 250 and bonds give 400. So now let's do the calculation. Now let's do the expected value analysis for the alternative investments of bond and stocks. When it comes to stocks, so you know that there is 1000 for 30% chance of economic uprising and 250 for 70% chance of economic downrising. So altogether it's give the result of 475. When it comes to bond, there is 600 for 30% chance of economic uprising and 400 for 70% chance of economic downrising. So altogether it's give 460. So under the expected value analysis, we are going to select the highest value, which is 475. So we are going to conclude the company to go for stocks. Why? Because it's give the highest expected value. Now let's do the expected opportunity loss analysis. So in the expected opportunity loss analysis, for each economic condition, we are going to identify the highest value. So in the economic uprising, it is 1000, and for the economic downrising, it is 400. Then what we are going to do is we are going to deduct that value from the value given in each condition. So you can see we are getting 0 for stocks in 30% economic uprising and 400 for bonds in the economic uprising and 150 for economic downrising for stocks and 0 for economic downrising in bonds. Now for the expected loss calculation, what we are going to do, we are going to take the table of opportunity loss. So now the opportunity loss should be multiplied with the probability. Now let's see how we are going to calculate the expected opportunity loss for stocks. For that one, first we have to take the value of the stock and then we have to multiply it with the probabilities given under each condition. Then we have to add them together. So we are getting 105 for stocks. So when it comes to bonds, we have to take the value of bond for each economic condition and we have to multiply it with the probability under each economic condition. So we are arriving at the value of 120. So now in the economic losses, what we are going to do, we are going to select the lowest expected loss. So here we are going to select the stocks with the lowest expected loss. So we have to give the conclusion for the company. We have to go for the investment of stocks. Why? Because it will generate the lowest expected opportunity loss of 105. Expected value of perfect information or EVPI is the difference between the expected profit under risk and the expected profit under uncertainty. So you can calculate it by the given formula. Under expected value of perfect information, first we have to calculate the expected profit under certainty. For that one, we have to take the highest value for each economic condition. So 1000 for economic uprising and 400 for economic downrising. Then we have to multiply these values with the probabilities given. So accordingly, the expected profit under certainty is 580. Now from this value, we have to deduct the expected value. So we are getting the result of 105 as the expected value of perfect information. So you can note that this is similar to the result of the expected opportunity loss. So if your answer is correct in the expected value of perfect information, you may have the same result of the expected opportunity loss. Now let's see the example 2. So here there are three alternative investments A, B, C, and there are three probabilities given. So for each probability, the values for alternative investment is given in this example. So here what we are going to do is, we are going to calculate the expected value analysis for these alternative investments. For that, we have to calculate the expected value for each probability separately, and then we have to add them together. Firstly, we are going to take 1000, then we are going to multiply it with its probability of 0.3. Then we are going to take 2000 and we are going to multiply with the given probability of 0.5. Then we are going to take 500 for investment A and we are going to multiply it with probability 0.2. Then we can arrive at the answer of 1400 by summing all together. Then for alternative investment B, we are going to take the value of 800. Then we are going to multiply it with the probability of 0.3. Then we are going to take 1200 and we are going to multiply it with the probability of 0.5. Then finally, we are going to take the value of 900 and we are going to multiply it with the given probability of 0.2. Then we can see the total answer as 1020. Likewise, we are going to do it for the investment C as well. When you do the calculation, you may see that you are getting 700 as the answer. So now what we are going to do, out of the 3 expected values, we are going to select the highest value, which is 1400. So we have to conclude the company that company have to go for investment A, which gives the highest expected value of 1400. Now let's calculate the expected opportunity loss. To calculate the expected opportunity loss, first we have to prepare the opportunity loss table. To prepare the opportunity loss table, for each probability condition, we have to identify the highest value. For probability 0.3, the highest value is 1000. For probability 0.5, it is 2000. And probability 0.2, it is 900. So now we have to deduct all the other values from the highest value of that particular column. So the opportunity loss table can be prepared as follows. Now we have to multiply the values with the probability for each alternative investment. So for alternative investment A, we are going to multiply 0 with 0.3, 0 with 0.5 and 400 with 0.2. So the expected opportunity loss is 80 for investment A. Now for investment B, 200 into probability 0.3, 800 into 0.5 and 0 with 0.2. So it will give 460. Now for C, 300 into 0.3 and 1300 into 0.5 and 200 into 0.2. Altogether, it gives 780. Under economic loss, we have to go for the lowest value. So in the expected opportunity loss table, we are going for 80, which gives the lowest value. So you have to conclude the company. Company has to go for investment A. Why? Because it's give the lowest expected opportunity loss. Calculate the expected value of perfect information. To calculate the expected value of perfect information, first we have to identify for each probability condition the highest value. For 0.3, it is 1000. For 0.5, it is 2000. And for 0.2, it is 900. So now we have to multiply it with the given probabilities. So the expected profit under certainty is 1480. then what we are going to do is we are going to deduct the expected value from the expected profit under certainty. So the answer is 80. So you can see that this is similar to the answer of expected opportunity loss, which means arithmetically this calculation is correct. In 2015 paper, we have three states of nature or three economic conditions E1, E2, E3, E4 and with the probabilities of 0.15, 0.3, 0.35 and 0.2. And there are three alternative investment A1, A2, A3 and we have the values for each status of nature with each alternative investment. In the expected monetary value or EMV calculation, we have to multiply the values with the given probability for each alternative investment separately. So, to calculate the expected value for investment A, what we are going to do is we are going to multiply 5,000 with 0.15, then 3,000 with 0.3 and 500 with 0.35 and 2500 with 0.2 and we are going to add them together. So we are getting 2325 as the EMV. So calculate the EMV of alternative 2. We are going to multiply 4000 with 0.15, 800 with 0.3 and 1000 with 0.35 and 600 with 0.2 and we are going to add them together. So we are getting 1310. So in the final alternative A3, we are going to multiply 1500 with 0.15, 2000 with 0.3, 3000 with 0.35 and 1000 with 0.2. So the final answer is 2075. So out of this investment in the expected monetary value, we have to go for the highest investment, which is 2325. So we have to conclude the company. Company have to select A1, which gives the highest EMV value of rupees 2325. So now we have to calculate the expected opportunity loss. To calculate the expected opportunity loss for each status of nature, for each economic condition, we have to identify the highest figure. So in E1 it is 5000, E2 it is 3000, E3 it is 3000 and for E4 it is 2500. So now what we are going to do is we are going to deduct all the other values from the highest element in each column. So we are deriving the opportunity loss table like this. Now what we are going to do is for each alternative investment, we are going to multiply the values with the probability. So for A1, we are going to multiply 0 with 0.15, 0 with 0.3, 2500 with 0.35 and 0 with 0.2. So we are getting the result as 875. Likewise, for A2 and A3, we are going to do the calculation. So in the expected opportunity loss, we are going for the lowest figure, which is 875. So you can interpret as the company has to select alternative investment A1 because it gives the lowest expected opportunity loss. Finally, we have to find the EVPI or the expected value of perfect information. To calculate the expected value of perfect information, first we have to select the highest figure in each status of nature. So here the highest figure under E1 is 5000. Under E2 it is 3000. Under E3 it is 3000. Under E4 it is 2500. So now what we are going to do, we are going to multiply the highest value with the probability in that particular economic condition. So you can see we are getting 3200 as the expected value under certainty. So now what we are going to do, from that value we are going to deduct the expected value. So we are come up with the solution for EVPI. Now to check the arithmetic accuracy, see your answer and compare it with the EOL, which is expected opportunity loss. If you are getting the same result, then your calculation is correct. Now let's see how to make decisions under conditions of uncertainty. There are three ways of making decision: Maximax, Maximin, Minimax. We are looking at the best that could happen under each alternative and then choose the best alternative with the largest value, or the maximum of the maximum payoff. Maximus is the best of the best, which means here people are more optimistic. As an example, just take a lotto player. They see the large payoff and they ignore the probabilities of getting it or not. In the Maximin scenario, we are considering the worst that could happen under each alternative and then choose the alternative with the largest payoff, or the maximum of the minimum return is selected. Maximin is the best of the worst. Here, most of the investors are pessimistic. The example that could given is a person who put their money into a saving account because they could lose money at the stock market. Minimax criteria try to minimize the possible losses for a worst case, and the decision making is based on the opportunistic losses. Minimax is the best of the worst losses. Let's consider a decision maker who has 1 lakh or 100,000 rupees to invest 3 alternative investment plans. So, he have the conditional payoff for the 3 investments. Those investments are stocks, bonds and savings, and there are 3 economic conditions, which is accelerated, normal and slow. In the Maximax criteria, we are going for the best of the best. So, for each economic condition, we are going for the highest or the best economic condition, which is the accelerated growth. So, we are going to select the values in the accelerated growth. Then we have for stocks 10,000, for bond 8,000 and for the savings 5,000. Among them, we are going to select the best. which is 10,000. So you can see we are going for the best economic condition. Then we are going to select the best economic payoff, which is best of the best. So according to Maximax criteria, we have to conclude that company has to go for stocks which gives the maximum payoff. In the Maximin criteria, we are going for the best of the worst. So here we are going for the worst economic scenario, which is the slow growth. Then we are going to pick the highest value in that economic condition, which is 5,000, which means we are going to select the worst, and from that we are going to select the best, that is the best of the worst. According to the Maximin, we have to conclude that company has to go for savings which gives the highest payoff. Minimax criteria is the best of the worst losses. For that we have to identify the highest element or the highest value for each economic condition. In the accelerated growth, it is 10,000, that is stocks. For the normal growth, it's also the stock with 6,500. For slow growth, it is 5,000 for saving. Then we are going to prepare the opportunity loss table. To prepare the opportunity loss table, from the highest value in each column, we have to deduct the remaining values. Now what we are going to do, from the loss table, we are going to identify the highest losses. So for the stocks, the highest loss is 9,000. For the bond, the highest loss is 4,000. For the savings, the highest loss is 5,000. Out of these losses, we have to select the lowest loss. So it is 4,000. Then we have to conclude the company. Company has to go for the bond because it will give the lowest loss among the other alternatives. So let's look at what is a decision tree. Decision tree is a map of possible outcomes of a series of related choices. A decision tree typically starts with a single node which branches into possible outcomes. Each of those outcomes lead to additional nodes which branch off into other possibilities. This will give a tree-like shape. There are three different types of nodes. The first one is a chance node represented by a circle. This shows the probabilities of a certain result. Then, a decision node represented by a square shows a decision to be made, and the end node shows the final outcome of a decision path. So here you can see the decision tree symbols. The symbol's shape, the name, as well as the meaning. Firstly, you have the decision node, then the chance node, then how we are going to reflect the alternative branches, and how we are going to reject the alternative, and the end point node. There are many advantages of decision tree. The first one is it's easy to understand. Secondly, it can be useful with or without hard data. And it needs a minimum preparation. Then, new options can be added to the existing trees without any hassle. It's easy to pick out the best of several options by looking at the decision tree. Finally, it's easy to combine with other decision-making tools such as expected value. There are several disadvantages. First one is a small change in the data can cause large change in the structure of the decision tree, which cause instability. The second one is less effective in predicting the outcomes of a continuous variable. And information may be biased when dealing with categorical data for large data sets. The calculation can become more complex when dealing in the uncertain environment and it combined with a lot of linked outcomes. So first we have to draw the decision node and there are two alternatives which is stocks and bond. So for the stocks there are two chances, that is economic uprising and downrising. So I'm going to draw these two branches of economic uprising and economic downrising, and after the end point, end node, I'm going to put the values. So what I'm going to do, I'm going to multiply these values with the given probability and get the summation of them, and I'm going to write it above the chance node, that is 475. Then for the bond, I'm going to follow the same method. So here also there are two chances or two alternatives, that is economic uprising and economic downrising. Then at the end of the branches, I'm going to put the end node and I'm going to write down the values. That is 600 as well as 400. Then I'm going to multiply the probabilities with the values and I'm going to take the total. And I'm going to write it above the chance node, which is 460. Now, under the decision tree, I have to select the best alternative investment, which is 475. So, I have to reject the bond. So, I am going to cut the alternative line with two straight lines. Then what I am going to do is, I am going to write the decision on the decision node. So, here I am going to go for the stocks. Let's see how we are going to answer the 2018 past paper. So in the 2018 past paper, you have three different alternatives of distribution, internet and direct method. And there are three different probabilities: high, medium and low. So first thing is, when it comes to decision tree, you have to draw the decision node with the square. Then you have to draw straight lines to represent the alternatives. Here we have to draw three different straight lines to represent distribution, internet and network alternative. Then at the end of each straight line, we have to draw a circle to represent the chance node. Then after drawing the chance node, what we are going to do, we are going to reflect the probability. So we are going to draw three different straight lines since we have three different probabilities, and on the top of that line we are going to write down the probability, and at the end of the line we are going to draw a triangle to represent the end node. So what we are going to do, we are going to multiply the value with the probability and we are going to write the expected value on the top of the circle of the chance node. Then out of these values, we are going to select the best value. Here, that is 56. Then we are going to reject all the other alternatives, which is we are going to reject internet as well as direct method. So we are going to cut it with two straight lines. Then what we are going to do is we are going to find the final decision. So here we are going for the distribution, which is having the highest expected value. And then on the top of the decision tree, we are going to write the distribution as our selection.